Today we are going to see two sum, and this is from LeetCode. Let's see the question. Given an array of integers, nums, and the integer target, return the indices of two numbers such that they add up to target. Okay, you may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so here there will be two inputs. One is an input array, and the other one is a target integer. Okay, so we have to find out two elements in this array such that if you add those two numbers, it will be equal to the target 9. So here 2 and 7 are the answers. And as they mentioned, right, there will be exactly only one solution. Okay, there won't be multiple solutions. And you should not use the same element twice. Right? So if the target is 4, you should not use 2 twice. Okay, and here you have to return the index of those numbers. So 2 and 7, the index are 0 and 1. Okay, let's see diagrammatically how we can approach this problem. Okay, first let's see a brute force algorithm, and next we'll see an efficient way of doing it. Okay, so let's take an input array 1, 2, 3, 4, 5, and our target is 9. So what we have to do? If you see it in a brute force way, right, you have to go through each element combination, right? Like whatever possible element combination. So what you will do? So we have to keep a pointer, one point at an element, and the other pointer should go traverse through all the other elements. The same thing you will repeat again. So keep now in the pointer in the second position, and the other pointer should traverse through the other elements, the remaining elements, right? If you do this way, then this 9 you will get the answer when the pointer is sitting at 4. The first pointer is sitting at 4 and the second pointer is traversing through 5. You will get your answer, right? So, but this involves a time complexity of order of n square, right? So let's see if we can do this in order of n, right? Okay, so the next algorithm is, so let's take the same array 1, 2, 3, 4, 5, and the target is 9. So here what we have to do is, when you go through each element, you know what is the other element you are looking for, right? So when you go to 1, you know the other element you are looking for is 8 because the target is 9, right? So 8 plus 1 is 9. So you have to find out in this array if you have that element 8, right? You have to search 8 in this set. Okay. So in a given array, if you want to find out an element is there in order of 1, you have to use HashMap, right? So what we can do, we can create a mapping table and we can load the value of this array as a key and the index as the value. So our hash map will be something like this: 1, 0, 2, 1, 3, 2, 4, 3, 5, 4. So this is the index and these are the value, right? So now if you go through this array, okay, your pointer is in 1. Now you can go to the hash map and search for 8, right? In order of one time. If it's not there, go to 2, search for 7, go to 3, search like that. You repeat the process. And when you go to 4, you will search for 5. Okay, you got 5 and take the index. Okay, index is 4. What is the index of the current pointer element? 4, which is 3. So 3 and 4 is your answer. Okay, so this algorithm solves this problem in order of n. So this is the efficient way of doing it. Okay. Okay, let's code it back in LeetCode. In LeetCode. So let's try the brute force algorithm first. Okay, so we have to create a loop. We have to start from beginning and we have to go till the last element, and in the inner loop we have to start from the next element of this element, right? So if your array is 2, 7, 11, 15, so I will be at 2 and the j should start from 7 till 15, right? So for int j is equal to I plus 1 and j less than, oh, and one more here, one more thing. Our first loop I, it no need to go till 15. It should go till 11 is the last but one element. So you can put start length minus 1. So j is equal to I plus 1, j less than start length and j plus plus. Okay. So here if nums of I plus nums of j equal to target, return new int array of I comma j. Okay, then that's all we have to do. Let's run it and see. Oh, we have to return something here. So return, okay, let's submit it. Okay, so this is the brute force algorithm. Let's do the other way. Let's use the hash map. Okay, so the same thing, you have to create a loop and load the hash map, right? So let's create a hash map. So a hash map of integer and integer. So is equal to new. Okay, so now after creating a hash map, you have to go through this array from the starting element till the last element, right? And you have to load this hash map. So a dot set nums of I will be your key and the value will be your index, right? Okay, so our hash map is ready. Now again you have to loop through each element, okay, and again you have to loop through each element, and let's take the balance in an variable. So balance will be target minus nums of I. Okay, okay, so when it's looping through, let's take the input is 2, 7, 11, comma 15. So when it is at the position 2, so we need 7. So balance will be set to 7. The target is 9. 9 plus 2 is 7. Then we need to find the balance in the hash map, right? So what we have to do, if a dot contains key of balance and I should not be equal to a dot get balance. Okay, so here you got it right. So let's take if the target is 4, if the target is 4 instead of 9, so you are at the position 2, and when you search, the balance will be again 2. So when you search for 2, the 2 coming from the hash map should not have the same index. That's why we have this other condition. The index coming from the balance from the hash map should not be equal to I. So that's why we have this condition. If you see the question, and you may not use the same element twice. Okay, that's why we have that condition. Okay, so if this both condition matches, then we are returning a new int array with value I will be our first index, and the second index will be coming from the hash map. Get balance. Okay, I think we are good. Let's submit it. Okay, so here we have to return something. Let's return null. Anyway, our code will not go to this place at all. Okay, I think we are good to go. Yeah, so if you see the runtime now, it's only 2 milliseconds. So it is faster than 80% of the Java Online submissions. Thanks, everyone.